Assalamu alaikum. This is lecture 4 of software requirement engineering, and in this lecture we are going to highlight the main aspects of vision and scope of the software projects. And then there will be some discussion about writing these documents in forms of software specifications. This lecture will also introduce you to the fundamental techniques of software requirement elicitation. So as it has been already discussed several times that product vision and project scope defines the top level business requirements, and these requirements are recorded as vision and scope documents. The product vision is an executive summary of the product, and it describes the reason for originating the product idea. So it is an general overview of our product in a whole system. The project scope, on the other hand, identifies what portion of ultimate long-term product visions the current project will address. It draws the boundary between what's in and what is out of the system's requirements. It also defines the details represented by the requirements baseline for the project. So in short, the product vision defines the ultimate goal of your product, that what you want to achieve as a business objective or the reasons behind your product idea. And the project scope defines what can be catered inside the product in using the project management lifecycle. And it also defines the measures to achieve the product vision. Again, the vision applies to the product as a whole, and it will change relatively slowly over time with respect to your releases of the each version. The scope pertains to the specific project or iteration that will implement the next increment of the product's functionality. Scope is more dynamic than the vision because the project manager adjusts the contents of each release with its schedule, budget, resources, and quality constraint. So as the diagram depicts here, that the project vision is on the whole project releases, that it remains consistent and consonant with each release with a very small amount of change. On the other hand, project scope is directly related to each release. For example, in the first release, the major focus can be on the development of user interface. On the second phase, the development of the background or database administration systems, and for further release you can prioritize different kinds of requirements. So VN is on the whole project, and the scope refers to the each release. For example, a federal government agency is undertaking a massive 5-year internet service development effort. The agency defined the business objectives and the vision for the system early in the process, and they won't change substantially over the next few years. The agency has planned some 15 individual releases of portions for the ultimate system. Each release is created as a separate project with its own scope description. So each scope description must be aligned with the overall product vision and interlock with the scope statement and the other projects. Project scopes usually help you to define the scope of the problem as well. For example, if you are going to build a bookstore application and you find out that the problem is that the textbooks are often not ordered in the time for the start of classes. So you investigate the problems further and ask different questions. For example, you may ask the manager that why this has happened, and the manager replies you that because we do not receive the book list from the instructors early enough. So as investigating further to each problem, you may reach to the conclusion for the specific problem in depth. And then you reach to the conclusion that the problem is not with the bookstore system. The real problem in the environment is that you should have to develop a system that helps you to make a decision support for faculty hiring at any university that will help to get overtake for the start of class. As it has been seen in the previous slide that finding out the exact problem scope is very difficult because it has multifarious underlying problems, and every problem can be seen as a symptom of some other larger problem, and you can keep on tracing the root causes forever if you are not very careful. So you have to identify the root cause of the exact problem by identifying the scope of the problem. And in this mechanism, you can follow certain approaches and ask different questions to find out the root cause of the exact problem. And first of all, you have to manage that is there a reasonable expectation that this problem can be solved. For example, if the problem is large enough and it cannot be solved independently, you do not have to apply your cognitive skills to solve the larger problem. Rather, you have to identify or divide the problem and conquer the subparts, and eventually it will solve the larger problem. And secondly, you have to ask the stakeholder that whether is it important to solve the problem, and do the local expert think that the problem is the one that matters. And finally, is this problem that someone will pay you to solve is an important consideration, because if someone is not willing to pay, you will not be able to solve the problem. So you can conduct a feasibility study which quantify the return on the investment. So once you are well equipped with the information about the scoping of your problem, then you have to scope your decisions as well and decide what should be done to achieve or overcome the problem's difficulties. So again, the same problem is identified regarding the bookstore applications, and there are several decisions are made to solve those problems. So you can go through the exercise by yourself. But you have to be very careful that there is not a technical solution for every problem, and by investing a lot of technology will not certainly help if you are not going into the right direction. So we could keep on throwing more technology at the problem forever without getting any positive benefits, and it is hard to decide when to stop adding extra bells and whistles. So again, you have to be very careful among selecting alternatives, and you can again ask several questions to scope the definition of your solution. For example, you can ask, is there a reasonable expectation that any alternative can be implemented independently of other options? And is there a reasonable expectation that implementing this alternative will help you to solve the original problem, or either it is just addition of technology without the use? So again, is this a solution that the stakeholders can live with? Do the local experts think that they would use all these functions. And finally is the solution that someone will pay you to build. Again, feasibility study should quantify the return on investment for each alternative. So this leads to you towards the definition of the vision and the scope document. The vision and scope document serve the purpose to collect the business requirements into a single document that sets the stage for the subsequent development work, and it is usually owned by the project executive sponsor who is paying, or a funding authority or a similar role, and usually it is written by the requirement engineers and the owner. The requirement engineer takes the inputs from several business stakeholders, and certain requirements are put to the vision and scope documents. The major inputs are from the customer or the development organization's senior management, project visionary, product manager, subject matter expert, and the members of marketing department. So here is a typical template for the vision and the scope document. Initially, the business requirements are identified along with the background and business opportunity studies along with the business risk. Then the vision of the solution is provided with the vision statement by specifying the major features and assumptions and dependencies of the solution. The third element specifies the scope and the limitations of first release and the subsequent releases. It also specifies the limitations and exclusions that will not be the part of your project solution. And finally, you have to analyze the business context along with the stakeholder profiles, project priorities, and the operating environment. So as with every project, the rudimentary step is the collection of business requirements, that why we need to develop this system. The primary benefits or will be the business owners or the stakeholders, sponsors, buyers, or users. And in the background study, you have to find out the situation that led to the decision to the build this product. This can be a problem or it can be a solution inquisitive quest. Background study also measures and identifies the key problems and how these problems can be catered to make a decision to build this product. Next, you also have to do some research about the business opportunity, that by building this product, what you can gain as a business objective. So you have to analyze the market opportunity, whether or not there are alternatives available in the industry or market, and how can you compete with those alternatives. You can also identify the business problems or the process improvement needs. A comparative evaluation of existing products is necessary and potential solutions. And this leads to the definitions of a business objective and most importantly success criteria. So once you have identified the background of the problem, the need for the solution, and how can you earn from this solution, the next step is to set out the guidelines that how you meet those problems and get the return on the investment, which is a very important business benefit, and it should be quantitative and measurable success criteria. For example, you can quantitatively measure that your product captures a market share of X% within Y months. For example, you can say there will be 10,000 users of your application in first 6 months, and from that quantitative and measurable success criteria you can identify the return on the investment. And you can also specify another example in which you have a business objective which says that you have to comply your product with the specific federal and state regulations. So apart from the business objective, you have to cater the needs of customers or market needs as well. So these needs are currently being met or not is a very critical indicator of your product success. For example, you are going to employ all the features that are offered in another product, your product will less likely to succeed unless you do the customer or market needs analysis. So you have to analyze that whether or not these needs are being met currently. So current problems that need the new product will address in this section. And finally, to conclude this section about the business requirement, you have to identify the major business risks associated with developing or on the other hand not developing this product. Risk categories include marketplace competition about the other products, the release timing issues, the acceptance of the users, etc. Potential loss from each risk is again another important consideration in the risk analysis, the likelihood of occurring and ability to control it. And you can also specify any potential mitigation actions in the project business requirements. So once you are clear with the need of developing your product and you have a clear articulation of your business objectives, customer needs, and you are well aware of the risk and how you can manage those risks to increase your products profits, then you can move to the vision of the solution. The vision of this solution is a strategic statement for the system that will achieve the business objectives specified in the first section. It provides the context for making decisions throughout the course of the product lifecycle, and it should not include the detailed functional requirement or project planning information. It should include the general outcome or the business objective that you want to achieve by building the product. And it starts with the vision statement. The vision statement should be concise and it should summarize the long-term purpose or intent of the new product. And it should be balanced view covering the needs of diverse stakeholders, and you can use a Moore's keyword template for writing the vision statement of your product. And you can typically cater different stakeholders in your vision statement. For example, you can start that your product is built for the target customers and statement uh, who needs the opportunity or the product solution. And then you can specify what you are going to build by the product name and what is the category of the product. And then you can briefly summarize the key benefits and compelling reason to buy or use your product, and you can give a one line comparative analysis that unlike this product is primarily competitive to the alternative, the current system or the current business product. And then you can give small description about your product. It can be a statement of primary differentiation and advantages of your product. Here is a typical example of a vision statement for the chemical tracking system. So you can go through this vision statement by carefully reading it and comparing it with the mood keyword specified in the previous slide. So once you are done with the major vision statement, then you have to move towards the more description of the vision features. So in the next subsection, you have to specify major features of your solution. So you can specify the name or the number of each of the new product's major features in a unique and persistent way. It will emphasize those features that distinguish it from the previous or competing products. So by giving each feature a unique label as opposed to the ballot permits tracing it to the individual user requirements, function requirements, and other system elements. So again, it is a generic major feature without main implementation. And after that, you can also specify some assumptions and dependencies that the stakeholders jointly made and avoid possible confusions, conflicts in the future. The major dependencies the project has on the external factors outside the control. For example, if your product has to implement pending industry standards, government regulations, other projects, third-party suppliers, and development partners. And then you move toward the scope and the limitation of your system. It specifies what your system is and what it is not. So it helps you to establish a realistic stakeholders expectations, and out of the scope requirements must be rejected unless they are so valuable that the scope should be enlarged to accommodate them with the corresponding changes in the budget, schedule, and staff. So scope defines what will be in your system in the current release, and if it is the something is the part of the VN and it is not in the current release, you have to specify that it is not in the scope of the current release. So you have to specify initially the scope of the first release along with the major features, quality characteristics, and in this statement you have to focus on those features that will provide the most value in the current release at the most acceptable cost to the broadest community in the earliest time frame. Then you have to specify the scope of the next few releases, that what features will be incorporated in upcoming versions of your product. For a stage evolution of the product, which features will be deferred and desired timing later releases. It also specifies quality characteristics like performance, reliability, and others as the product matures. Short release cycles helps by providing frequent opportunities for learning based on the customer feedback. It This section also includes the limitations and exclusions. By definition of the boundary between what is in and what is out of is a way to manage the scope creep and the customer expectations. And limitations and exclusions also list any product capabilities or characteristics that a stakeholder might anticipate but that are not planned for inclusion in the product or in the specific release. So the business context is the concluding section of your vision and scope document. And in the first subsection, it specifies the stakeholders profiles. Stakeholders are the main actors or persons who are responsible for the development and the use of the product. Stakeholders are the groups or organizations who are actively involved in a project and the, who are most affected by its outcome or were able to influence its outcome. So stakeholders focus on the different types of customers, the target market segments, and the different user classes within those segments. Each stakeholder profile should include the following information: the major value or the benefit for each stakeholder, improved productivity, automation of previously manual tasks, ability to perform entirely new tasks, and compliance with the pertinent standards of regulations. Then set the priorities for the project and 5 dimensions of software project For example, features, quality, schedule, cost, and stop. What features or scope is included, what is the level of quality, what are the schedules, how long, how much it will cost, and how much resource persons are required. So each dimension fits in one of the following categories on any given project. The priorities must have can have a constraint which is a limiting factor within which the project manager must operate. For example, you have set a constraint on the quality attributes or cost, and the project manager has to operate within the specified cost and quality attributes. The priority can have a driving force and a significant success objective with a limited flexibility for adjustment. It can also have a degree of freedom, which is a factor that a project manager has some latitude to adjust and balance against the other dimensions. The project manager's primary goal is to adjust those factors that are degrees of freedom to achieve the project's success drivers within the limits imposed by the constraints. It helps you to respond appropriately when the project requirements or the realities change. Suppose marketing suddenly demands you that you release the product with 1 month earlier than the scheduled. How do you respond? So you defer the certain requirements on the later release, you shorten the planned system test cycle, and you pay your staff overtime or hire contractors to accelerate the development, and you shift resources from other projects to help you out to meet these objectives or project priorities. So if you carefully analyze this statement, you say you have a sudden demand, which is a constraint or a driving factor, and the demand or driving factor is the release of the product, which put limits on the schedule, which is 1 month earlier than the schedule. So you have to respond by changing all of these five dimensions. For example, you have to change a few features to incorporate the major ones. You have to compromise on the qualities. You have to change the schedule. You have to put more cost and the staff. So the project priorities dictate the actions you take when such eventualities arise. Operating environment is also a consideration of the business context and environment in which the system will be used, and vital availability, reliability, performance, and integrity requirements are met is called the operating environment. And operating environment will significantly influence the system's architecture. For example, a system that must support widely distributed users who acquire access around the clock needs a significantly different architecture from that one employed by the co-located users only during the normal working hours. There are a variety of ways to represent the scope visually, and these scope representation techniques include context diagrams, which shows the context of the system, ecosystem maps, feature trees, and event list. However, other techniques are also used, which will be discussed subsequently. So the first term to visually represent the vision and scope of your system is the context diagram. The scope description establishes the boundary and connections between the system we are developing and everything else in the universe. So that is in the universe means that is not of the part of our system scope or which is outside the boundary of our system. In the context diagram, graphically illustrates this boundary, and it identifies the terminator outside the system that will interface to it in some way. For example, we have a system and we have two different external elements such as data flow, which is fed to the system, and there is an external entity which is related to system in some other way, and this box defines the system scope boundary. For example, the context diagram of the chemical tracking system is displayed here, and the chemical tracking system is placed in the center along with the entities that interact with the chemical tracking system, and the relationships are defined by specifying a verb form. So as you can see, major stakeholders are users and entities which interact with the system are identified and their relationship is specified. You can go through the details of this context diagram by yourself that will help you to identify the partial context diagrams in the typical chemical tracking system. The entire system is depicted as a single circle. The context diagram deliberately provides no visibility into the system's internal object, processes, or data. That means though no internal functions are displayed in the context diagram. The system inside the circle could encompass any combination of software, hardware, and human components. Therefore, it could include the manual operation as a part of the entire system. The external entities are in the rectangle that can represent the user classes. For example, in the previous slide, chemists, buyers, and organizations such as health and safety departments, and other systems such as training databases or hardware devices, for example, barcode reader. The arrows on the diagram represent the flow of the data, such as a request for a chemical or a physical item such as a chemical container between the system and its external entities. So another form to represent your system is called ecosystem map. An ecosystem map shows all of the systems related to the system of the interest that interact with one another and the nature of those interactions. An ecosystem map represents a scope by showing all systems that interconnect and that therefore might need to be modified to accommodate your new system. Ecosystem maps differ from the context diagrams in that they show other systems that have the relationship with the system you are working on, including those without direct interfaces. You can identify the affected system by determining which ones consume the data from your system. So when you reach the point that your project does not affect any additional data, you have identified the scope boundary of system that participates in the solution. So here is a typical example of an ecosystem map again for the chemical tracking system. It shows the different entities that how they interact and what is the relationship of the interaction. The ecosystem map, again the systems are all shown in the boxes such as purchasing system or receiving system. In this example, the primary system with working is shown in the bold box. But if all the systems have equal status in your solution, you can use the same box files for all of them. Again, the line shows the interfaces between the systems. For instance, purchasing system interfaces with the chemical tracking system. Lines with the arrows and labels show the major pieces of the data are flowing from one system to another, and some flows can also appear on the context diagram. Another way to represent a system scopes is the feature tree. A feature tree is again a visual depiction of the product features organized in logical groups, hierarchically subdividing each feature into further levels of detail. The feature tree provides a concise view of all of the features planned for the project, making it an ideal model to show executives who want a quick glance at the project scope. The feature tree can also show up to three levels of features commonly labeled as level 1, level 2, and level 3. The level 2 features or sub-features of level 1 features and level 3 features or sub-features of level 2 features. Here is an example of a feature tree of a chemical tracking system which is divided into three different systems called the order of the chemicals, health and safety system, and inventory management along with the subsystems. The main branch of the tree is the middle. In the middle represents the product being implemented. Each feature has its own line or the branch coming off that is central to the main branch. The gray boxes represent level 1 features which are on the top and the bottom of the previous slide. The line coming off the level 1 branch or the level 2 features. Again, search and chemical requests are sub-features of order chemicals. The branches of level 2 branch are the level 3 features. For example, local lab search is a sub-feature of search. Another way to represent the system boundary and scope is the event list, and the event list identifies external events that could trigger the behavior in the system. The event list depicts the scope boundary for the system by naming possible business events triggered by the users, time-triggered events, or the signal events received from the external components such as hardware devices. The event list is only named the event. The functional requirements that describe how the system responds to the events would be detailed in the software requirements specification by using event responsible table. So here is an example of a typical system for chemical tracking, and external events are listed. For example, chemist place a chemical request and then the chemical container barcode is scanned, time generated and compliance report, vendor issues the new chemical catalog, new proprietary chemical system is accessioned into the system, etc. and so on. Each item in the list states what triggers the event. Chemist does something or the time to do something arrives will identify the event action. An event list is useful for scoping because you can allocate certain events to be implemented in a specific product releases or development iteration. You can notice that how the event list complements the context diagrams and ecosystem maps. The context diagram and ecosystem maps collectively describe the external actors and systems involved, whereas the event list identifies what those actors and systems might do. So there is a difference between the two diagrams, however they are same to represent the final scope of your business, your product and project boundaries. So you can check the event list against the context diagram and ecosystem maps for the correctness and completeness as follows. You can consider whether each external entity on the context diagram is the source of any event. Do any of the action chemist trigger behavior in the chemical tracking system? You can consider whether any systems in the ecosystem map lead to the events for your system. For each event, consider whether you have corresponding external entities in the context diagram or systems in the ecosystem map. If a chemical container can be received from a vendor, does the vendor appear in the context diagram or ecosystem map? So if you find a disconnect, consider whether the model is missing an element. In this case, vendor did not appear in the context diagram because the chemical tracking system does not interfere directly to the vendor. However, vendor is included in the ecosystem map. So the second part of the lecture of ours today is the elaboration of the requirement elicitation techniques. And the requirement elicitation techniques are the heart of the requirement development, and it is the process of identifying the needs and constraints. So you have to focus on these three words, that in requirement elicitation you have to identify the needs and the constraints of the various stakeholders for the system. Elicitation is not the same thing as gathering requirement, nor it is a simple matter of transcribing exactly what user say. So you have to interpret and construe these requirements into proper elicitation. It is a collaborative and analytical process that includes activities to collect, discover, extract, and define requirements. Requirement elicitation is used to discover business, user, functional, non-functional requirements along with the other types of information, and it is perhaps the most challenging, critical, error-prone, and communication-intensive aspect of the software development. We will see the impacts in a very brief amount of time in the upcoming slides. And the requirement elicitation is all about determining the needs of the stakeholders and discovering what the user wants. So how do you know when you are done with the requirement elicitation technique? So in general terms, there is no concluding solution and no simple signal to indicate that you have clearly articulated all the requirements. So you will never be completely done, but following cues suggest that you are reaching to the point of diminishing returns on the requirement elicitation. So if you reach any of these following outcomes after the elicitation, you may think that you have achieved enough elicitations. So if the users can't think of any more tasks or goals, you may feel that you have identified correct or all requirements. So if the user repeat issues that have been already covered, is again an indicator of completeness. If a suggested new requirements are all out of scope, and if proposed new requirements are all of true priority, or again provide you a indicator that you have elicited the correct requirements for the current release. If the users are proposing capabilities that might be included sometime in the lifetime of the product, is again a harbinger for completeness. So another way is to create a checklist for common functional areas considered for your product. Examples are, for example, you can consider for error logging, backup and restore, and access, security, reporting, printing, and preview capabilities, etc. So there are many elicitation techniques that can be employed on software projects. In fact, no project team should expect to use only one elicitation technique. So you can use an amalgam of different techniques to elicit the correct requirement. So there are always many types of information to be discovered, and different stakeholders will prefer different approaches. One user might be able to clearly articulate how he uses the system, whereas you might need to observe another performing her job to reach the same level of understanding. It depends a lot on the communication skills of the users or other stakeholders. Elicitation techniques include both facilitated activities in which you interact with the stakeholders to elicit requirements, and independent activities in which you work on your own to discover the further information. So we will discuss both types of techniques in the subsequent slides. Facilitated activities primarily focus on the discovering business and user requirements. The independent elicitation techniques supplement the requirement that user present and reveal the needed functionality that end user might not be aware of. And most projects will use a combination of both facilitated and independent elicitation activities. Each technique offers a different exploration of the requirements or might even reveal the completely different requirements. So here are some traditional techniques that you can look into the previous systems or ask the gut feeling about the requirements, such as introspection of the thoughts or requirements. So you can read the existing document, you can analyze the hard data collected, or you can conduct the open-ended or structured interviews to ask users about their requirements. You can also create questionnaires and conduct surveys to gather the requirements, and you can also conduct meetings with the potential stakeholders to elicit requirements. You can also use the collaborative techniques such as focus groups and brainstorming to identify new requirements or the requirements that cannot be elicited by the use of the traditional techniques. And you can also use the rapid application development workshops, prototypes, and participatory design to help you to identify the actual requirements. And you can also use some contextual approaches such as ethnography, which help you to understand the working principles of human to achieve any desired task in the real environment, and then you can incorporate those activities into the system to achieve the desired functionalities. So we will discuss each of the techniques briefly here. However, you can implement these techniques in any use case to further enhance your understanding and grasp of the techniques. So first technique discussed is the traditional one, which is the introspection, and it is the first method applied by the aspects. Introspection is the self-observation and the reporting of inner thoughts, contemplations, desires, and sensations. And introspection relies on your and user's thinking, reasoning, and examination of his or her or your own thoughts. And it is quite useful in some situations, but it had some problems because you cannot think of the requirements on your own or think of the requirements in your thoughts or desires which can be translated to the system requirements. Another useful technique in the requirement elicitation is the background study. There are different sources of information to conduct the background reading, such as there can be some company reports for using a previous software or manual system. You can use organization charts and policy manuals. You can read the job descriptions and report documentations of existing systems. It has a certain advantages which help the analyst to get the understanding of the organization before meeting the people who work there, and it also helps you to prepare the other types of fact finding, for example by being aware of the business objective of the organization, and it may tell you the detailed requirements for the current system. However, it has certain disadvantages because the written documents are often do not match up to the reality, and it can be long winded with much irrelevant detail. And it is appropriate when you are unfamiliar with the organization being investigated for the development of new project. The third traditional technique is the hard data collection, and it identifies the collection of the facts and figures, financial information, reports used for decision making, survey results, or marketing data. So you can conduct a sampling to select a representative set from the population, and you can use different ways of sampling such as purposive sampling, simple random sampling, and stratified random sampling or clustered random sampling to choose a subpopulation or a part of the population and use to collect hard data. In the hard data collection, the sample size is the most important indicator, and it sets the balance between cost of the data collection analysis and the required significance. The process is illustrated as the decision about what data should be collected, for example, banking transactions, and determination of the population to be sampled, for example, who will be the part of the data collection process and what data will be collected. And then you choose the type of the sample. For example, you can use the random sampling and pick any person from the population, and then you choose the sample size. For example, every 10th transaction in the banking transaction application. Interviews are the most common ways to elicit requirements, and it is helps the user to understand the software system and the need it has to cater. Interviews are very traditional source of requirements for the inputs of both commercial products and information systems. Usually, agile projects make the extensive use of interviews as a mechanism to get their users' involvement, and interviews are easier to schedule and lead to the large group activities such as requirements workshops. So there are two types of interviews: structured, which sets the agenda fairly between open questions, and there are open-ended questions in which you can ask any questions and there is no preset agenda. There are many advantages of interviews such as rich collection of information and good for uncovering opinions, feelings of the users or stakeholders, their goals as well as hard facts. And it can probe in-depth and adapt follow-up questions that the person will tell you. However, it has few disadvantages because large amount of qualitative data can be hard to analyze and it is hard to compare different interviewees. And interviewing is a difficult skill to master. It is difficult to ask right questions. So you have to be very careful about the unanswerable questions, and you have to be very careful for the implied knowledge. You have to be very careful to ask question about the tacit knowledge because that is very much obvious to the users but not obvious to the development team. So you have to ask the explicit questions that how a task is achieved or what a particular word means. So interviewers' attitude may cause the bias is also another problem with the interviews because some people are not very much willing to give you the accurate information. There are certain tips that you can encounter in the interviewing technique for the software requirement elicitation. You begin with the interview with an innocent topic to set people at ease because making the connection with the person is very important to gather the most of the user requirement, because if you do not set out the other person or if you do not uh, accommodate the other person and the other person is not comfortable to talk to you, there will be very much very little communication between the interviewer and the interviewees, and the elicitation interview will not be very productive. And whether the score in the last night, for example, you can discuss different common questions such as asking themselves about their hobbies on their likes and dislikes, and then you can move toward the topic. So you should ask the permission to record the interview, but uh, put tape recorder in front of the person and say that they can turn it off it anytime they want to say something that should not be recorded. So you have to ask easy question first because it will help the person to gather the insights of the problem and then moving toward the detail. So you can also conduct a follow-up for interesting leads and ask open-ended questions at the last of your interview. There are different suggestions for interviews, so you can go through the suggestions here. For example, you should establish a rapport, a relationship of the trust between yourselves and the interviewees, and you should stay in scope and prepare questions and straw main models ahead of time. You should suggest the ideas and listen actively. Another traditional approach is the surveys and the questionnaires, which can help you to collect a large amount of information in a very short amount of time from a large number of people. And you can collect these surveys and questionnaires without meeting people, such as sending them questionnaires or doing them online. So you can collect attitudes, beliefs, and characteristics by creating surveys and questionnaires. However, there are some disadvantages. For example, simplistic categories provide very little context, and there is no room for users to convey their real needs because the questionnaires and surveys will have specific questions which do not cater the actual needs or desires of the users. Again, you have to watch for the bias in the sample selection. People may be willing to support one cause over the other, and you have to consider for the bias in the self-selecting respondents. So you have to select a wide variety of the respondents rather than your favorite one, and watch for the small sample size and open-ended questions. So there can be different forms of errors in surveys and questionnaires. For example, sample and sampling bias errors can occur, and some information is not collected from every member of the target population, and this will lead to the potential bias in how the population is sampled. So for example, if you are creating a web-based survey, so you can most likely to exclude the non-internet users. And there can be a coverage error which occurs when not all of the target population is included in sampling, and there can be a measurement error which occurs when responses are not counted accurately. For example, there are some ambiguous questions that lead to the responses that are hard to classify. And the non-response error is the most significant one, and it occurs when the significant number of population do not participate to answer the question. Similar to the interviews, the another form of the requirement elicitation is the meeting, and it is used for summarization and feedback. For example, you meet with the stakeholders toward the end of each stage to discuss the result and information, to conclude a set of requirements, and to agree on a design. Use the meeting to confirm what has been learned, talk about findings. Meetings are most important to the managerial team. It is used to move a system development from project forward and need to determine objectives for the meeting. So you should plan the meeting carefully, set the schedule for the meeting and arrange for the facilities, prepare an agenda and distribute it well in advance, and keep track of the time and agenda during the meeting, and follow up with a written summary to be distributed to the meeting participants. Apart from the traditional techniques, there are some group elicitation techniques, and there are two types of group elicitation techniques. The first form is the focus groups, and the second is the brainstorming. Group elicitation techniques has certain benefits which are more natural interactions between people than the formal interviews, and it can gauge reactions to stimulus materials such as mock-ups or storyboards. However, there are still disadvantages when creating teams. You can select an unnatural groups, the uncomfortable participants that interact that may not interact with each other very well. And you can also select a group which thinks similarly, and you may only provide superficial responses to the technical questions, and it requires a highly trained facilitator for the groups. Again, sampling bias error is again a problem here, and you have to watch for dominant the participants and some partners in the group which do not participate, or the submissive participants. So let's discuss the focus group. A focus group is a representative group of the users who convene in a facilitated elicitation activity to generate input and ideas on the product's functional and quality requirements. They are particularly valuable if you are developing commercial products and do not have the ready access to end users within your company. So it includes the users who have used previous version of the product similar to the one you are implementing. So you either select a pool of users who are the same type and hold multiple focus groups for the different user class, or select pool of representing the full spectrum of the users classes to the everyone is equally represented. Focus group must be facilitated. You will need to keep them on topic but without influencing opinions being expressed. Do not expect quantitative data analysis from the focus groups, but rather a lot of subjective feedback that can be further evaluated and prioritized as requirements are developed. Participants in the focus group can normally do not have the decision-making authority or requirements. One of the most used techniques in the requirement group elicitation techniques is the brainstorming, and this is the elicitation technique that has a number of benefits because it encourages the participation by all parties present, that everyone has to participate in the brainstorming session. It allows the participant to piggyback on one another's ideas, so either they have to support or give the inverse ideas for any particular brainstorming idea. So it has high bandwidth. Many ideas can be generated in a short period of time, so focus is on the quantity rather than quality. The results typically indicate the number of possible solutions to whether the problem is posed. It encourages out-of-the-box thinking, that is, thinking unlimited by the normal constraints. Brainstorming usually have two phases. In the first phase, you generate as many ideas as possible, and the phase is referred as idea generation, and the goal is to delineate as many as possible. And it focuses on breadth of ideas and not necessarily the depth. In the second phase, you reduce those ideas. In the idea reduction phase, and the primary goal is to analyze all the ideas generated. Idea reduction includes pruning of the ideas, organizing, ranking, expanding, and grouping, or defining them, or so on. Another technique of the requirement elicitation is conduct of workshop. A workshop is a structured meeting in which a carefully selected group of stakeholders and content experts work together to define, create, refine, and reach closure on the deliverables such as models and documents that represent user requirements. Workshops are facilitated sessions with multiple stakeholders and formal roles such as facilitators and a scribe. The facilitator plays a critical role in planning the workshop, selecting the participants, and guiding them in a successful outcome. The business analysis frequently facilitates the elicitation workshop. A scribe assists the facilitator by capturing or writing down the points that come up during the discussion. It extremely it is extremely challenging to facilitate subscribe and participate simultaneously and do a good job on all three. Workshops often include several types of stakeholders, from users to developers to testers. They are used to elicit requirements from multiple stakeholders concurrently. Working in a group is more effective for resolving disagreements than is talking to people individually, and workshops are also helpful when quick elicitation turnaround is needed because of schedule constraints. So here are some tips for creating workshops. Establish and enforce ground rules. The workshop participants should agree on some basic operating principles after the rules are set. Ensures that the participants follow them. Examples include the times, the breaks, the electronic devices unused, and the holding one conversation at time and expecting everyone to contribute. And you focus comments and criticism on issues rather than on people. To fill all the main team roles, a facilitator must make sure that the following tasks are covered by people in the workshop. There should be a person who takes notes. There should be a person to keep track of the time and scope, and there should be ground rule management and making sure everyone is heard. So depict a plan uh, and show the agenda beforehand. So create the plan of the workshop ahead of the time and communicate them to the participants so they know the objectives and what to expect and can prepare accordingly. So again, stay in the scope and watch out for the traps such as off-the-topic discussions such as design exploration. Keep the participants focused on the session objectives and while assuring the, them that they have future opportunities to work through other issues that arise. So again, use parking lots to capture items for later consideration and discuss some time box ideas. Consider allocating a fixed period of time to each discussion topic without wasting your time. You should keep the team very small, but you should include the right stakeholders because small groups can work much faster than the larger teams, and you should avoid to have too many cooks. Requirement elicitation workshop that involve too many participants can slow a contentious call. And you should also keep everyone engaged, that everyone is listened and the ideas are valued and appraised to the specific standards and needs. Another form of the workshop is the joint or the rapid application development workshop, and these workshops focus on different principles such as there should be group dynamics and you should use workshops instead of interviews. You should also use visual aids along with the visualization of media, wall charts, large monitors, and graphical interface. These workshops should be organized and there should be a rational process for techniques such as brainstorming and top-down analysis. So these workshops focus on what you see is what you get documentation approach, and each session results in a document which is easy to understand and it is created and upon during the session. So you have to be very careful in choosing workshop participants. They should be the best people possible representing various stakeholder groups. Workshop should last about 3 to 5 days and it must turn a group of participants into a team. Session leader makes sure that each step has been completed thoroughly and session leader steps in when there is a difference of opinion. Meeting room should be well equipped for the presentations, recording, etc. The most significant form of the requirement elicitation technique is the prototyping. Prototyping is the initial version of the system which is available early in the development process. In software systems, prototypes are more often used to help elicit and validate the system requirements. An essential requirement for prototype is that it should be possible to develop it quickly so that it can be used during the development process. So there is some functionality that may be left out and normal mechanism of management in quality assurance can be ignored in prototyping. Non-functional requirements such as performance, security and reliability measurements may be less stringent and so on. There are two types of prototyping and one is referred as throwaway prototyping. It is intended to only help elicit and develop the system requirements without the further use. The other form of prototyping is called evolutionary prototyping, and in this type, the prototypes are intended to deliver the workable system quickly to the customers, and the same prototype is evaluated over the time to produce the final outcome of your project. The prototype serve as a evolutionary prototype and throwaway prototype, but in both cases it serves many advantages, and an overall feasibility and usefulness of the system can be captured through prototype before high development costs are incurred. Prototype also hinders the development of the system cost, and in the initial phases the system user interfaces are developed as prototypes. The prototypes help you to develop system tests that can be used later in the system validation processes. The system prototypes can also be used for back-to-back testing with the final system if you are using the prototypes in the evolutionary prototyping system. Prototype implementation requires careful study of the requirements. This in itself often reveals requirement inconsistencies and incompleteness. However, there are certain trade-offs against the benefits of using prototypes. Usually, there are training costs that are required to teach the users to use the prototypes, and there are some development costs which are involved in the prototype development, and there are extended development schedules due to development of prototypes, and prototypes may represent the incomplete system overview. There are three possible approaches in which allow a prototype system to be developed relatively quickly. So for example, you can develop paper prototypes where mock-up of the system is developed and used for system experiment without developing the exact functionality into the prototype. So you can use the basic prototyping techniques such as modeling to visually represent the system and their working without putting the functionality into the prototype. Another form is the Wizard of Oz prototyping, in which a person simulates the responses of the system in response to some user input. So you can conduct an experiment in which the user is facilitated with the user interface and they initiate an action, and in return a user or system administrator responds back to the user with the outputs from the system. You can also use the automated prototyping where a fourth generation language or other rapid development environment is used to develop executable prototypes. And the final and most important element of the requirement elicitation is the participatory design, and it is originally cooperative design, also known as co-design. In the participatory design, you have to actively involve all the stakeholders, for example, employees, partners, customers, and citizens. It is the design process to help ensure the results meet the needs and the issues. It is mostly used in the high-end customer applications and the high-budget customer applications. Another form of requirement elicitation is the ethnography. Ethnography is an observational technique that can be used to understand the social and organizational requirements of the software. Ethnographic studies, by their very nature, cannot be carried out according to a formula, and they are dependent on the personality of the ethnographer, the type of the process being studied, and the people involved in the process. It is rarely used in the small scale projects. So in the ethnography elicitation technique, for the initial steps, you have to conduct the ethnographic analysis of the customer base, and then you have to conduct a briefing meeting which describes the system objectives. These ethnographic discussions and findings are coupled with the system prototyping to generate the system prototypes, and users are expected to interact with the user system generated prototypes, and then you find out the focused ethnographic results, and these are then combined with the further ethnographic analysis to define the final product. So that is the end of today's lecture, and if you want to study more about the topics of the requirement elicitation techniques, you can read the paper titled A Walkthrough of the Requirement Elicitation Techniques. And if you want to learn more about the other techniques discussed, such as requirement engineering process and techniques, you can go through the recommended book, and you can read the chapter 4, 5, and 7. If you have any other questions, you can ask me through any of the medium, or you can conduct a question and answer session. Thank you very much.